Day 4, conversion of radicals. We're going to spend a few days on this, not just one day. Day 4. So if you look at this multiplication property for radicals, what it's saying is that if you have a product of radicals, you can just, like if you have a product inside a radical, you can just split the radical. So let me give you an example of that. So example, square root 5 multiplied by square root 5 is the same as square root 25. Okay, that's what it's saying. It's saying like, so what's 5 times 5? So what it's saying is that the product of two radicals, if they're separate, like root 5 and root 5 are separate, it would be the same as if you just multiplied 5 by 5 first and then took the radical of that. Okay, so it's the same as if you multiplied 5 by 5 on the inside. This unit, or pardon me, this lesson, very important, this lesson here. Like, it might not seem important in like this unit in Math 10C. You might forget about it later in the year, but this one will come back in Math 11 and Math 12. You have to be able to know how to do these simplification of radicals. So what we're going to do is we're going to factor the radicand. Do you guys remember the radicand? The thing inside, very nice. Factor the radicand using perfect square factors. Or perfect cube factors. So when do you think you want to use a perfect square factor? Yeah, good, when you have a square root. Excellent. And then when do you think you're going to use the perfect cube factor? When you have a cube root. So we're going to have to be able to factor, which for some of you will be harder than for others because some of you know your times tables better. But let's take a look. So first of all, what are the factors of 80? Always start with 80n itself. So 1 and 80. 2 and 40. Does 3 work? No, 3 would go to 81, not 80. 4 works. 4 and 20, good. Does 5 work? 5 and... Sean? 5 and 16, good. Does 6 work? Sean, look, can you just try instead of just blurting stuff out? Does 6 work? You'd go 80 divided by 6, right? 6 doesn't work? You would get a decimal when you divided it, right? Okay, so does 7 work? 8 works, right? 8 and 10. Does 9 work? And then how do you know we're done there? Good. The numbers have like balanced. They've met each other. Like as the first list increases, the second list naturally decreases, and then they get close to each other. There's no more options left. So of those factors, how many are perfect squares? This one has the 4, right? Do you see how that one has a perfect square of 4? Is there another choice? 16's a perfect square, right? times 4, right? Is there any other perfect squares on that list? Do you guys remember the perfect squares? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6. You guys remember these? You have to know these. If you don't, how can you use your calculator? That y equals button? Y equals, and then you type in x squared, and then you go second graph to the table of values, and then you have the table in front of you. So I want to factor square root 80 into 2 factors. Which one should I choose, the 16 or the 4? Yeah, you want to choose the larger one because then you don't have to simplify twice. Okay, so choose the larger option. Choose the larger option. And then watch what we can do. Square root 80 is the same thing as square root 16 multiplied by 5. Do you agree with that? Do you agree with that statement? The board is lying to you because it didn't refresh. There it is. Is square root 80 the same as square root of 16 times 5? Do you agree with that? And then we can use the property that we've been told is okay to do up here. That property, we're going to, what are you going to do? You're going to take the product and you're going to split it. See how it splits like that? We're going to split it. So this square root 80 is going to be rewritten as square root 16 multiplied by square root 5. What's the square root of 16? 4. And that's the final answer. 4 root 5. Okay, so this is called simplifying radicals. All right. The square root of 80. 8.944279191. Was that a perfect square root? No. So that number is irrational. We simplified it to 4 multiplied by the square root of 5. Look at those two values. You see how they're identical? They're identical? So they represent the same value. One is simplified and the other is not. So in this class we call this 4 root 5 like this, we call that one mixed. And we call this one entire. You will be asked to do this on the exam. You will be asked to do this in Math 20. And you have to be able to do this in calculus. So if you plan on taking any of those courses, you got to know this. Oh, we're supposed to use prime factorization. We're not going to do that. That method using prime factorization is not as efficient. It's not as efficient. This is the most efficient way. Okay, now for cube root 144, we can't choose perfect square factors. We have to choose perfect cube factors. So do you guys remember those perfect cubes? What's the first perfect cube you can try? 8. 2 times 2 times 2, right? What's the next perfect cube you can try? Good, 3 times 3 times 3. And the next one? 64, 125. These are some options for you. Of those options, which one factors 144? Probably 8, I'm thinking. 8 works. Does 27 work? You should be trying this. 144 divided by 27? No. 144 divided by 64? No. So we have to use 8. The cube root of 144 would be the same thing as the cube root of 8 times 8 times what? Louder? Thank you. Some people are following along. Because I just did 144 divided by 8 in my calculator. 144 divided by 8. Now, which one of those is perfect? 8 or 18? The 8. So when we split these, I like to put the perfect one first. No, it ultimately doesn't matter, but just for cleanliness, put the perfect factor first, and then you can simplify. So the cube root of 8 is 2, and you still have to multiply by the cube root of 18. Okay, I'll give it a minute, and then I will show you what this looks like on the calculator. All right, so math, cube roots have in the math button, you have the cube root there. We were doing 144. And then what do we get? 2 times the cube root of 18. And we need the same thing to show up. This is like a check that we did it properly. Oh, thank gosh. Right, Anthony? Following along? Okay? So this is how you double check that you've done it properly. How do you guys feel about this? Think you could handle that? Okay. These two are for you guys to try. That. Well, this time, I don't want you to like, does 63 divide by 2? No. Does 63 divide by 3? Yes. I don't want you to go through that process. Are we doing square root or cube root? Square root. So I just want you to try numbers on this list. Because this is the list of perfect squares. So try 4. Does 63 divide 4? No. Try 9. Does 63 divide 9? Yes. So try that one. What is 63 divided by 9? So we could rewrite 63 as 9 times 7. You agree with that? Which one of those is perfect? The 9. So put square root 9 first, and then the square root 9 simplifies to 3. I bet now that it's up there, you're just like, wow, that was easy. And now check square root 63. Okay, now for the cube root 108, do I try the numbers on the first list? Those are perfect squares, right? So now I have to try the perfect cubes. And like will 125 work? It's way too big, right? So you know you only have 3 choices. I think even 64 is too big. It's 8 or 27. You only have to check 2. All right, so for 108, what were your options? 8 and 27. Did 8 even work? No. So does 27 work? 108 is the same thing as 27 multiplied by 4. 27's the perfect cube, and it simplifies to 3. I just want you to look at the way I've written this. I know sometimes people with their notation, they might confuse themselves. Look at the size of my 3's here. 3 is a whole number. It's the same size as the 4. The little 3 is the superscript. It's the index. So it's written smaller. You have to realize that this is 3 multiplied by the cube root of 4. Like if I put x, y on my board, what does it tell you? X times y. Agreed? So that's like this one. 3, what's written right next to the 3? The cube root of 4. So this is 3 times the cube root of 4. All right, let's keep going. 72, 72, 72. Which ones on my list work? 9 works. 4 works. And is there any others? Wow. You have choices for 72. 2, whoops, my bad. 4 works, 9 works, and 36 works. Which one should you choose? Because if you choose 36, it'll be done the quickest. If you choose 36, that'll be the most efficient way to do this. What happens if you choose a lower number? Very good question. Watch me. I'll choose the lowest possible number. Yeah, you have to do it over and over again. So 72 is the same as 4 times 18. The 4 would come out as a 2. 18 is the same as 9 times 2. The 9 would come out as a 3. You'd be left with 6 root 2. What if I just chose 36 right off the bat? What's the square root of 36? You just get 6 faster, yeah. Okay? So there's no specific way that you have to do this, but there are more efficient ways. What about the cube root of 40? Sanaya, you okay? 40. Which one on my cube list divides 40? Yeah, good. That one's an obvious one. So you have cube root 8. What do you have to multiply by to get to 40? 5, right? And the cube root of 8 is 2. So that one's done. 2 multiplied by the cube root of 5. Okay, so you guys can try the next 2 on this page. I'll walk around and help. So here's an example where a student chose 25 as the perfect square. 25 times 8 is 200. That's perfect. 25 was simplified to 5. That's perfect. But you're not done. Why aren't you done here? What's inside of the number 8? A perfect square of 4. Very nice, you guys. So you'd have to keep going. 8 is the same thing as square root 4 times square root 2. And this square root 4 would be simplified to 2. And 5 times 2 is 10. So this was the final answer you were looking for, 10 root 2. What would have been the more efficient choice? 100, yeah, because 200 is the same as 100 times 2. And 100 comes out as 10. How about the next one, cube root of 32? You got to use 8, right? when you're doing cube roots, always check for 8. 8's the obvious choice. And then the cube root of 8 is 2. So hopefully you guys are finding some success. So in these ones, this is like you're halfway done. You got to keep going. So for this one, keep simplifying. Keep simplifying. So I'll remind you that it's always multiplication. So what would work for 20? What factors 20? 2 works, but then you get 10, so 2 and 10. No, can't use 2 and 10. 4 and 5. Which one of those is perfect? The 4. The 4 would be square rooted to become 2. So you could put the 2 there, and the 5 stays inside. And then you'd be left with 8 root 5. So there are different styles here. Like, you could do like a little factor tree. What perfect square divides 50? 5's not perfect. But 25's perfect, right? Is 25 on this list? Now, do you see how quickly I was able to think 25 is related to 50? Some of you won't think like that. Those numbers, you know, maybe your parents didn't sit at the dinner table with you every night doing times tables for like the first 5 years of your life. Like my parents did. Times tables was like a nightly routine for me. So, with that being said, and you know who you are, and you want to do well, you make sure you know how to generate that list of numbers on my whiteboard, right? You buy the technology that will help you. You know how to type it into there, and then you have it available to you on the exam, right? So how does the 25 get simplified? What would 25 come out as? A 5. And then that 5 has to get scaled by the 3, and you end up at 15, right? So I'll write this all out. 3 multiplied by square root 25 multiplied by square root 2. I'll highlight it for you, for some of you that need that. This 25 times 2 is the 50. But the 25's a perfect square, so it would come out as 5. And the 3 is still there though, and it's all multiplication. So 3 times 5 is 15 root 2. Okay, and I'll leave these last 2 for you guys to try. Okay, I'll put up the solutions to these 2. You're not ready for them? Just the answers? How about I just put it up? 12 is the same as 4 times 3. The 4 simplifies to 2. And then you get 10 root 3. I saw a lot of people with 10 root 3, so I'm comfortable giving you guys that one. Now, the cube root of 54, which, I don't think 8 divides 54. Oh, 27 does though, right? It'd be 27 multiplied by 2. 27 times 2 is 54. And the cube root of 27 is 3. The cube root of 2 is not perfect, so it has to stay inside the radical. And then you get 6 cube root 2. Okay, so I'll put the screen back up in a second, but your assignment for this weekend is just right here. So you have You have 15 minutes, 20 minutes to get it done in class, so no excuses. Excuses are for the weak.